Hi everyone. So today is the day 7 of the September LeetCoding challenge, and on this day, we have been given to solve this problem, that is reverse linked list. So in this problem, we have been given a singly linked list, and we will be given head to the to a singly linked list, and we need to reverse this linked list, and we need to return the head of the reverse linked list. So for example, this was a linked list, and in this, one was referring to two was referring to three was referring to four, and four was referring to five. So after reversing, like the new new head should be pointing to five, and this five should this five should refer to four, four should refer to three should refer to two, and two should refer to one. So we can take a look to this example of only two nodes. So one was referring to two, so after reversing, two should refer to one, and we need to return the head to this node. And yeah, there is also an example in which there is an empty linked list. So we are given a null pointer pointing to the head, so we can return a null pointer in that case. And yeah, we can take a look to the constraint. So the number of nodes in the list is in the range from 0 to 5000. So there are at most 5000 nodes in the list. So we can see that as per the constraint, add order and squared solution would also be okay to pass all the test cases, but we will be doing it using order and approach only, because that's more optimal. And there's one more thing, that the value of the nodes are ranging from minus 5000 to 5000. And there is a follow-up that a linked list can be reversed using both iterative approach or recursive approach. So we are asked whether we can implement both or not. So first I will be solving it using iterative approach, and after doing that we'll be taking a look how we can do it using recursive approach. So recursive approach is more simpler than iterative approach. I guess we should start with recursive approach. So yeah, first I will be implementing it using recursive approach, then we can move to iterative approach, right? So first we will handle the corner cases. First I will be making a linked list to understand the implementation. So yeah, so this is a linked list, and here this one is pointing to this. So this is our linked list. So the last node is pointed to null, and what we need to do, we will be converting this reversed list function into a recursive function that will kind of reverse. Suppose this is given to this function, then it will reverse all the part that will be towards the right of the that is coming forward of this node. So basically it will reverse all this part, and it will return us the head to the reversed linked list. So first of all, we can handle the corner cases. So if head is null, we can return null, but since head is null, we can also return head. And another case is when there is only one node. So in that case, head.next will be null. So since there is only one node, we can return this linked list also, because there is one node, there is no sense of reversing the linked list, it will stay the same. And there is one more case, that is the general case, when there are two or more nodes in the linked list. So what I will be doing, I will be first reversing this part of the linked list, and suppose we are said to reverse this whole linked list, then I will be first reversing this linked list except the one node, and after we have reversed this linked list, we can do what, we can erase this link So I will then erase this link, and I will then form a new link in this direction. So this way, this whole linked list will get reversed. This is the recursive approach we will be using. And after reversing this linked list, we will get the linked list, the head to the reverse linked list. So we will be returning that head for this whole linked list. So this is the approach of doing this problem. So first of all, like we will reverse the linked list except the first node. So we need to pass head pointer next to reverse this part. So this, after this function, like this whole part will get reversed. Now we need to store, like we need to save the head that was given by this function, because this is the like a new head of the whole reverse linked list. So after we have done this, then we need to erase this link that was initially present. So we will not erase it first. We will first make a link from this node to this node, because if we'll erase this, like we won't be able to like retrieve this node. So first we will, so this head dot next will point to this node, and this node pointer next should point to this head. So we have now made a link like this, and now we need to erase the initial link that was from this head to the next node. So it can be done easily. Head pointer next should be null, and we need to return the new head. So this function should work. So since like every recursive function is like doing number of iterations equal to, like, yeah, we can say that for one linked list there is only one iteration, and for two linked lists there will be one iteration plus one iteration, kind of two iteration. And for three linked lists, basically the recursive function is an order n function. So like if we are solving it for n plus 1 nodes, so this will be order n plus 1. So basically this will be a order n for this n plus 1 nodes also. So basically this is an order n solution, and it will be a space complexity can also be set order 1 if we are like ignoring the function calls, like while like we are not using an explicit space, but like behind the scene for calling these recursive functions, recursive stack of n, like this recursion stack will contain at most n entities, so that way it is more like order. But yeah, like we are not using any explicit space complexity, so it will be order 1. So this is the solution. So we can try to run it on the sample test cases. Yeah, it is working. So we can submit it. Yeah, so it got accepted. So now we need to solve it using iterative approach. So like this corner cases will stay the same, so I will keep it. So now we need to solve it using iterative approach. So we are not allowed to use this reverse linked list function inside this function. So first of all, I will be like restoring the linked list. So this is the linked list, initial linked list, and we will be solving it using with the help of 3 pointers. So I will be calling these 3 pointers as, I will call it previous pointer, I will call it current pointer, and I wanted to call it next pointer, but since next is a reserved keyword here, so to avoid confusion, I will be using latest. Latest, we can call it latest. Yeah. So like these three pointers will be pointing to three consecutive nodes. So what we can do, we can start reversing this whole linked list by first erasing this link. So let us initialize these pointers. Yeah. So let us keep on implementing and understanding this approach. So let us initialize these three pointers. So this list node previous will be equal to head. This list node current will be equal to previous.next. And this list node latest will be equal to current.next. So we have got the three pointers initialized to first three values, and now we will first doing what? We'll be first erasing this link, and after this link get erased, we will have situation like this, like there is no link between this previous and current pointer, and there is a link from current to latest. So we need to change this link pointing from current to latest into a link pointing from current to previous. So we will do something like this. Current dot, first of all I will be erasing the link from previous to next. So I can set it null to erase it. And now we need to do what? We'll be using a while loop. Basically we will repeat this same thing until we encounter some terminal situation. So what we'll do, I will be doing a current dot next equal to previous. So this will erase this link and make it to point here. So it will get erased, and then there will be a link from this node to this node. Now we can do what? We can change this previous pointer into current pointer, and current pointer into latest pointer, and latest pointer to the next of the latest pointer for the next iteration. So we can do it here like this. This previous can be assigned to, yeah, so this current can be assigned to previous. This current will become equal to latest, and this latest will become equal to latest dot next. So we have got all these three pointers moved to one place, right? And now we are again in the same situation. So we can again do this same number of steps. So we can keep doing this until this latest will point to this null node, null pointer basically. So this latest will point to this null pointer, this current pointer will point to this, and this previous will point to this. So in this situation, there won't be any link between these two nodes, and all the previous nodes would have reversed, right? So we need to, this situation will look something like this. And now we can complete this whole reversing thing if we'll be making a link from this current to previous. So first of all, we need to break if we encounter such thing. So we will only do this, we will only run this while loop if the latest is not null. So if latest is null, we will be breaking out of this while loop. So now we are out of this loop. So we only need to make a link from current latest to current. No, from this current to previous. This is the current and this is previous, and then we can return this current node because this is the new node of the reverse linked list. And now we can analyze the time complexity. So since we are like running this while loop for only at most 10 times, so the time complexity will be order n. And since and the like all the iterations or all the processes happening inside this while loop is order one operation, so it will stay order n. And since we are only using 3 pointers to do this problem, so like the space complexity will be order one. So we can now like try to run it on the sample test cases. Yeah, so it's working, so we can submit it. Yeah, it got accepted. So thank you guys. See you tomorrow again with a new September LeetCoding challenge.